want to start. Okay. Stretch it out a little bit. Left to the right. Good evening, everyone. It's another episode of Dan Does Data special anniversary. I can't believe I've been doing this silliness for a year. It's also an anniversary of TensorFlow when it was sort of formally released. I say formally, officially, whatever you want to call it. As it turns out, I haven't actually installed TensorFlow on this computer since I had to put in a new hard drive and a bunch of other stuff. I just never got around to it. So I thought that today, what I can do is actually install TensorFlow, just like my first video a year ago. So let's hop right into that. Let's start like we did last time at the TensorFlow webpage. For those of you who don't know, TensorFlow is a deep learning library with bindings in Python and C++. It makes it easy to build neural networks and other graph-based computations. Let's just click Get Started, because I hope that's helpful. We want to use pip installation over here. That's going to save us a lot of headache. I'm almost certain. Or maybe Anaconda, but I like pip. Pip is a big fan. Oh, hey, look. Use pip 3 for Python 3. That's super convenient. Super convenient. Oh, install pip for pip 3. Excuse me. Select the correct binary to install. This is still a little goofy, but that's the way the business is. A year ago, they did not have Python 3 versions. I was super upset. TF bind. Oh my goodness, this is different. I think I have Python 3.5. Python 3. Yes, I do. So that's the one I want. Requires CUDA Toolkit 8 and cuDNN version 5. For other versions, let's see if we can actually get this to work. We're gonna find out. If we might have to install some of this other stuff. I thought I had that. Alright, so export TF binary URL. And presumably, and then you can say install. Python 3, hey, what do you know? Rather than saying go to this particular URL, you set that as an environment variable and then you go. Not too strange. Let's just install that right there, and that'll download. So I'm not looking to accomplish anything particular today. I just wanted to thank everyone who's ever watched the show, or has left a comment, or has upvoted on Reddit or anything. Thank you for supporting me for a year, and I hope you got something out of it as well. That I get a lot of comments and emails from people who say, oh, it was a really great way to learn because you're just doing it live interactively. I make mistakes that are very human. Hopefully you can understand and get a better sense of what's going on. Man, I love the future where I can download 100 megabytes in like less than a minute. That's so good. Oh, I grew up in the dial-up era and it was horrible. Horrible. This is so good. I have to upgrade my NumPy apparently. I really hope this doesn't break the rest of my stuff. Really hoping that. That would be horrible. Using old pip, that's fine. I don't care about using old pip. Let's import TensorFlow, right? TensorFlow STF. So I need a newer CUDA. So as always, that's going to be a problem. But let's see what kind of help they have. Enable GPU support. This is probably CUDA installation. See, this is something that irritates me. I have to have the absolute latest. Here it says CUDA 7.0 and cuDNN version 3, but that's a lie, apparently. Is there an older TensorFlow I could use? So I don't need CUDA 8 or whatever. No. Gotta use CUDA 8, it looks like, for any of their GPU stuff. Alright, so they need to update their docs on that. But that's okay. Oh, did TensorFlow even work with my GPU? Yeah, you know what? That's true. TensorFlow did not even work on my GPU, so I don't know why. I swear. Yeah. Now that I'm remembering that, my GPU is too old. I don't have the new enough Nvidia compute capability. Because I have a Nvidia-SMI GeForce GT 620, which was old 4 years ago. But it gets the job done, surprisingly. Let's see. I think it has compute capability 2.0. Compute capability. Architecture. Oh, maybe it is 3.0. Kepler members of the 600 and the following add the following standard features. Yeah, maybe not. GeForce? Here we go. GT. Scroll way down. 660. Those are all GTX. Hang on. 640. Mobile. 640. 620. Here we go. 2.1. Jeez. Why is this? Because that's what, yes, compute capability. So I can actually not use the GPU anyway with TensorFlow, and that is why I use Theano for most of my regular usage. So we are actually going to sudo pip3 uninstall TensorFlow, and that's it. That's all there really is to it. I install TensorFlow and then I remove it. Now, what we're actually going to do is use the CPU version, which is still not too bad. Let's see here. So that saves me some headache, in fact. We're going to use Python 3.5 CPU only, yes. So if TensorFlow ever adds legacy support for older GPUs, I will probably give it a more thorough, I'll consider using it for my daily regular machine learning use, but until then, like if I can't use the GPU with TensorFlow, and I can with another library that has very similar syntax, then I'm going to use the other library. And in this case, I use Keras most of the time anyway, so I don't even have to look at the lower syntax. It saves me an incredible amount of effort. Oh my goodness. Okay, let's try this one more time. And now let us import TensorFlow as TF. And boom, look at that, it imported. Well, there's people in the chat, someone has, that's not a graphics card I'm familiar with, but no CUDA for you at all. That is unfortunate. I have heard of people working on OpenCL implementations of a lot of the deep learning type libraries, and I really hope that takes off. CUDA is good, I really like CUDA, but it's always good to have a fully open source solution as well. So that is TensorFlow now started. So you can do all this TF dot and find all these little cool things. I don't even know if I have my old TensorFlow folder in here. I don't think I do. No, that's just the project I started just now. So I don't even have my original code from when I did this a year ago. I guess I determined that was not important and I did not need it. You know what? We are no longer MNIST for ML beginners. We are now deep MNIST for experts, which is, oh, easy ML. Oh, we'll have to get that later as well. Super fun, super fun. All right, so the GPU is gone. Forget the GPU, it doesn't exist. MNIST is a classic library of digit recognition, sort of very simple image classification problem. Aha, you can just load the data right here. See, like half of this I remember a whole bunch and half of this I don't, is the problem. So I don't remember you being able to say tensorflow.examples.tensortutorials.mnist import input data. That is not something I remember. What does input data give me? Oh, the fellow in chat, you've got that AMD graphics card. Yeah, that is unfortunate for CUDA. Yeah, when I did purchase this computer, it was mainly for gaming usage, but I also thought I might want to do some CUDA programming, so I made sure to get one with an Nvidia graphics card. And they do good work. It's good hardware. I appreciate it. Functions for downloading and reading MNIST data. That's just funny. Oh, it's a module. It's a module. Oh, interesting. Cool. And then you get MNIST. And of course you get it in the one-hot format. So basically, make an array that's as many samples as you have times however many classes. And for each sample, whatever class it actually represents, a 0, a 1, a 2, a 3, whatever, you put a 1 in that segment, and you put zeros elsewhere. So it's sort of a bloated format, but it makes the matrix math work a lot easier. I can just say mnist.train. What kind of sass? What is this? I am the X property. That is not helpful. Well, that's the actual data set. I'm thinking this was a function. That is not the case. It's a TensorFlow.MNIST This I'm not familiar with. MNIST is lightweight clash with sort of the training, validation, testing data sets. Oh, okay, cool. Start a TensorFlow interactive session. That's right, you gotta have a session. This is all like, I don't look at this on a daily basis, so I always forget. Yes, you have to create a session, and graphs only exist in a session. There we go. And then you'll say like session.run or something when you want to run the things in that session. That's right. And yes, to set up your you have to tell TensorFlow what computations you want to do, and they have to be specified as a graph. That's right. So you'll say add this input to that input, add this number to that number, multiply the result by 2, and spit out this output. None of that gets executed yet. It just specifies the graph. You can sort of think of it like compiling, if you're familiar with a language like C or Fortran or something like that. And you've got variables. That's right. So we're going to want some inputs. Bam. Look at that. So X is going to hold our 784 pixels from each MNIST digit image, which is 28 by 28. Here we've just flattened it all out. We don't really care what the order of the pixels is, as long as it's the same for every image. And in fact, it's going to be the first row, followed by the next row, followed by the next row, so on and so forth. But this is just a placeholder. This is just making, like, allotting memory in our graph. Flip 32, in fact, 4 bytes in our graph, saying, hey, we're going to be putting inputs in this place. And this y bar, or y underscore, is going to work similarly. That's where we're going to put in the output class in the one-hot format. So again, that's just a placeholder. You haven't computed anything yet. We haven't put any data in there. We're just telling TensorFlow we're going to be putting things in there. And when you say placeholder, that's a special type of TensorFlow variable that says, hey, force me to give you some data later. Variables, however, are a little more generic. Variables are objects in TensorFlow that it can change, or you can stuff in special values for, things like that. In this case, we're going to have a weight matrix, which is 784 times 10, because each pixel will affect probabilities in each of the 10 classes. So that's why you need a weight for every pixel for every class. And likewise, you need a bias term for every class. Really, you could get away without a bias term on the last class. That one is actually just an extra variable you don't need. But the math, it's just easier to think about it if you just say 10. And I don't think it hurts you that much to do something like that. But these variables don't exist in a vacuum. They need to be initialized as something. Here you're saying tf.zeros is how you initialize them. Here you're saying it's a placeholder, you're going to give me those values. Come on. Follow me. There we go. You need to initialize your variables. So they give you this nice convenient tf.initialize all variables in the session. So any variables you have, they'll go in there. Why is the variable y underscore instead of y? Because later we're going to have y as our predictions, I believe. You could call it y. It doesn't really matter. But that's just to let us know that that's for the training data rather than what we're predicting, I think. I might be wrong. I might have this backwards. Did I actually? Let's read it briefly. See what it says. The target output class is y bar will also constitute a tensor. Indicating digit class who the corresponding image belongs to. Yeah, I think that's just going to be the training data of what the actual classes are. Predicted class, because y is a function. So this is our first actual graph computation right here. So y, which is of course whatever class we want to predict, or in this case it's like a score or series of scores that we're going to predict. we're going to take a matrix multiply between x, those pixel values, and w, our weights, and we'll add the sort of contribution from the bias terms. And we'll use that to get whatever this y value is. And this y value is sort of giving us a score on each class based on these weights. So 784 of the weights will apply to one class, another 784 will apply to another class, and so on and so forth. Okay, and then you need to tell TensorFlow how do you fix your model, because your weights are terrible. So you have to say, how do I measure how good my model is? Is y a keyword? Y is not a keyword. Y is just what we're using here. That's all. Well, let's change our color scheme a little bit. Let's be adventurous. Much better. Much better. So use cross-entropy to determine how good is this model. How good is the model. And all that's really saying is, if for the class that is, for the actual class that this image represents, say it represents a 7, I'm going to predict some probability. Maybe, I don't know, 70%, because we like 7s. That's not as good as if I predicted 90% for the correct class. You get to ignore the other classes, in a sense. Mathematically, it doesn't look like you are, but really you're ignoring the other classes. You're only interested in the class that is correct. We could go into the actual formula. I don't think that's important to look at right here, right now. But that's all the cross entropy is really saying. And what are we comparing our cross entropy between? Our training data, the actual known labels in this one-hot format. That's why you had a 1 and a bunch of zeros in other places. And y, the values, the class probabilities we've predicted right here. I could have sworn we're missing a... I feel like I missed a... Oh no, softmax crossing. Okay. And so you're predicting this value. This looks like a totally linear equation. It is, but we're using softmax cross entropy with logits. And so this takes this linear equation, and each score you're computing for each class becomes e to that score, is how it works. And then your share, your probability, is just going to be e to the score over sum of e to everyone else's score. To everyone's score, excuse me. Your share of the overall exponential score. That's all that means. It's called softmax, it's called multinomial logit, it's called logistic regression, it's called a lot of things. But that's all that is, and they're just sort of baking it in here for you in this tf.nn, neural net stands for NN, or NN stands for neural net, and they say softmax with cross entropy. I'm almost certain that you could say tf.nn.softmax yourself, and then you could probably just say tf.nn. Oh, you can't say cross entropy. Interesting. Things have changed a bit in the past year, or even like 4 months ago when I was using TensorFlow most recently. Was it? Oh shoot, it's November. 11, it's July. Alright, it was more like 6 months ago I was using TensorFlow. How the time flies, how the time flies. Y is not defined. I didn't actually run this. Okay. But that's all that is. So that's a way to tell how wrong your model is. If you know how wrong your model is, and you can take derivatives, and TensorFlow does this automatically for you, I believe in a semi-numerical fashion, then you can compute the gradient, which tells you, hey, adjust your model like this to be more correct. If you do that a little bit for each data point, you can slowly nudge your weights to where they should be. And that's sort of how the vast majority of these machine learning models work. You define some function to make your predictions. You define some function that tells you how wrong you are, your loss function. You compute the gradient, and you move a little bit in that direction for a little bit of data, a little bit in that direction for a little bit of data. There are much more complicated structures and more interesting things to do, of course, but that's sort of the crux of it. Then you need to train the model. Yeah, here we go. So first, you tell your model how you want it to train. So you need an optimizer. That's what this gradient descent optimizer does. This says, given that you've got this cross entropy, hang on, that we defined earlier, how wrong our model is, we tell gradient descent says how much of the gradient do we move at each step. And in this case, we want to minimize that. So we said tf.train.grade. What are the options? That's always, what are the options? There are so many options. There's a lot of optimizers. The Atom optimizer is popular. There's going to be RMS prop is another popular one. There's tons. So gradient descent is totally fine. Actually, I want to see tf.train. I'm fighting back a sneeze right now. Oh my gosh. The stochastic gradient descent an option? No, I bet regular gradient descent is stochastic. Train.gradient descent optimizer. It doesn't say. Oh well. Not a big deal. And again, these are just parts of your graph. You haven't done any computations yet. The cross entropy, just part of your graph. That sort of like code you're going to compile. In fact, it's in a literal sense, you're going to compile it, especially if you're using a GPU. And then it will be run when you do that. The train step, also very similar, just part of the graph, essentially. Then how do you actually do the training? Which I think this should be called out more. Oh, what is this? Two spaces? No. Because you're using something like gradient descent and not like the normal equation in linear regression, you're not extracting all the information from your data in a single pass. You're just moving a little bit, because you don't want to move too far. You don't want to overtrain. So you got to look at your data multiple times. And hence you have multiple epochs. Each epoch is one full cycle through your data. Or is that even how this is working? This doesn't even, this little training business doesn't even have the concept of epochs, I guess. It's just their MNIST data object gives you this way to just grab the next 100 images. So we're going to look at 100 images, we're going to train on those 100 images once, then we'll grab the next 100, then we'll grab the next 100, then we'll grab the next 100. We'll do this 1,000 times. So that's 100 times 1,000 is 100,000. However, there's only like 60,000 images or something. Train images. Oh, it is an array. Cool. 55,000. Okay, maybe it's 60,000, and maybe it's test. They're pulling out 500. 10,000 there. What about validation? 5,000. Huh. Interesting. Okay. For some reason, I thought that was more. There was 70,000 total, I guess. Whatever. Except we're not going to use range. I'm going to from TQDM import TQDM. Yeah, that's what I want to see. So TQDM is a sweet progress bar for Python. If you've ever had to sit through the pain of something running and not knowing if it's working, in-object is not iterable. Right. Range 100. Let's run that. Nice. So what do? We grabbed 100 images at a time, and we ran this train step.run. Train step, of course, was our gradient descent optimizer node on the graph. The thing that says, hey, given that the model is wrong, fix it a little bit. And this feed_dict object is how you define things that are your placeholder variables, your data inputs. So x is going to be whatever the images are, and y is going to be whatever the known classes are. So it's just that simple. And then you've trained it, and you say, oh great, how do I actually, look at the results? That's of course going to be the part that you're interested in. So w might interest you. If I say w.eval, that's not right. Interesting. Sesh.run w? No. Interesting. I'm going to look at the website in a second here. Import NumPy as NP. There we go. Huh. Yeah, that's a little odd. Okay. Oh, well, we need to find more nodes. Clearly. So, no. So, how do you figure out how well your model did? So they're saying use this correct prediction object. And all you're doing is instead of computing your loss function with this cross-entropy where being closer to correct is better, the correct prediction just asks, what is the class with the highest probability? If that's the correct class, bang, you nailed it. Doesn't matter how close it is, just matters if you nailed it. That's why you're saying this tf.argmax. So find the index with the highest value. And because we have it in this one-hot format, that's going to tell us which class it is. Likewise for our known data. And so this should just be another node in our graph. Yeah. This is tf.tensor and it's some kind of equal to thing. It's not we didn't do the computation yet. You're going to have to compute that. So that just figures out how many are equal, and then you do this reduce mean thing to get the sort of accuracy overall as a percentage. That's all. You convert the prediction into a float, a vector of floats, a tensor of floats, if you will, from like a bool, a bunch of zeros and ones. And then reduce mean just says, what is the mean value of all these zeros and ones? So if I have 75% ones, the mean value will be 0.75. That's all. It looks a little wacky, but it's really not, it's not rocket science. And then how do you actually get your answer then? That's what you want to know. So, if you have an interactive session, you can ask any node and say, hey, .eval. And if you feed him some inputs, like say, the testing images and the testing classes, it will evaluate that node. And accuracy is just some computation that we define. And it says, hey, 91%, which for logistic regression is pretty typical. It's not actually that great. Common, I think the top models I've seen are like 99.6 or something, maybe 99.5% on this particular data set, the MNIS. It's sort of considered a solved problem, and like the ones that it misses are really bad. Getting 92% accuracy on MNIST is bad. Almost embarrassingly bad. You know what, that's okay. It's allowed to be bad. You're just learning. You're figuring it the heck out. That is all that it's about. All right, how much of this do I want to go into? That was, of course, like plain old logistic regression. TensorFlow can do neural networks, and that's why they're building convolutional neural nets right here. You're going to define some convenience functions for yourself for the weights and the biases. You don't have to think about it all the time. You're going to improve your variable initializations, so to be truncated normal instead of just zeros. You're going to take convolutions. You're going to actually care about the structure of the image and say, hey, this pixel is next to this pixel, so these should be related in some way, right? And then you define a lot more things. You're going to reshape your images to be actual images, which is important. You're going to use different activations instead of just one softmax layer. You're going to use this rectified linear. You're going to have a sigmoid layer maybe. No, they're using all real use. You're going to say, hey, network, ignore like half of my inputs. Just ignore them because I don't want to overtrain. I don't want to just memorize the input. Because the machine learning models have so many parameters, it becomes really easy for them to just memorize input. And then your model is not really generalizable or useful outside of the exact data that you fed it. Depending on your situation, that might be good or bad. Like there are situations where memorizing the data is the thing that makes sense, and that's what you want to do. Okay. Well, they get 99.2%. That's not too bad. Wow. All right, I'm actually curious now if I can do that. If that's actually true. 99.2 is better than I would have thought. I would have thought 98 or 99 or something like that. So let's see what we can do here. So again, I'm just real quickly going through this. If anyone has any questions out there in the audience, now is a perfect time to ask about them, because I'm just copy and pasting, so it is not mentally taxing in the slightest. And again, I just want to thank everyone for whoever watched the channel or anything. I hope it's been useful for you. I hope to continue doing more. If you have an opinion on what new videos of the channel should be, please let me know. If you want to see more machine learning videos on libraries I haven't looked into, if you want me to look more at libraries that I have, if you'd rather see more like applied project, like the font recognition model that I made this summer, or the autonomous car that I've been working on this fall, send me an email, leave a comment on Reddit, wherever you want to go. Just let me know what kind of content you would like to see. If you want to see like pure, not machine learning, just more hardcore statistics, we can do that too. That's I don't think that's going to be as interesting in a live stream video, but we can try it out. That is honestly the purpose of this, just to try out, is live streaming data science something that makes sense? Is it educational? Is it entertaining? Will I become a famous celebrity? Probably not, but that's okay. All right, we're almost there. Just a couple more lines here. We're probably going to end early tonight, because I got places to be, you know? Even though it's the anniversary night. Who works on their anniversary? Come on. More applied projects, that's what I hear. Oh, that's good, because I like doing applied projects more than I like just looking at the same old. So that's good. If you have an idea for what kind of project you'd like me to work on, we can also consider something like that. I haven't spent a lot of time working on text, so that is something that we could consider. That'd be a lot of LSTMs and recurrent neural networks, stuff like that. Let's see how long this takes. Oh no, we're not going to do a TQDM here. Oh, we are, rather. So that's definitely a possibility. I'm going to return to the self-driving car at some point. Assertion error. Yeah, figures. No, stop. So I get for not having auto indent on. There we go. Yeah, that's going to take 35 minutes to run. So I'm impatient. I'm not going to let it run for that long. I'll let it run for just a minute or two here. So yeah, that's all I want to know from people. What kind of content do you want to see? Well, going forward, we'll see what is out there. What are good projects to do? What makes sense in the context of a live stream? It has to be something that's approachable enough that most people watching can pick it up, that doesn't have too much data, that I can train something in at most a couple minutes to get something that makes sense and does anything. And a project that's interesting, hopefully engages a lot of people, things like that. And hopefully something that I'm interested in too. Like the font recognition I kind of threw together for another project, and then I adapted it to something to be used in the channel. The autonomous car projects have been used as work I've been doing at Fubar Labs. We're building an autonomous like mini tractor. All right, so there seems to be a consensus on applied deep learning projects. So I think I will be continuing to go down that line. And hopefully that will be interesting. Gosh, this is taking, I do 10 iterations a second. That's miserable. Oh my goodness. So I do 10 batches a second, and a batch is only 50. So I'm looking at 500 images a second. Can I debug a CNN using some of the tools out there? What tools do you have in mind? That would be a question. Because I introduce lots of bugs into my own convolutional neural nets. I debug them in Python usually. There's a lot of Python debugger. How to output machine learning data in real time on a microcontroller. Oh, that's a tough one. That's a problem that we have with the autonomous car. Let's see. We are not done with the autonomous car models. Still more to come with autonomous. Keras Deep Stream Quiver Engine. I heard about the Quiver Engine. That sounded kind of cool. Deconvolution. I like that. I might also do a video on like auto encoders or something. I'm of mixed mind about that. I have a side project going on involving those. I don't have as much experience with those. I kind of like this deconvolution idea. So you make an image generative model. The opposite of a convolution is, of course, a deconvolution. You take a smaller amount of information, you spread it out. So that's something, an interesting idea. All right. Well, I appreciate a lot of people coming out tonight to check out the anniversary video. I realize it wasn't really any new content. We're just going over TensorFlow again. That's all right. That's sometimes it's good to just go back to your roots, see where you came from. And that can help us figure out what the way forward is going to be. So if anyone has any other thoughts, please leave a comment, send an email, whichever. I'll be glad to take those in mind. And we'll see what's in store for the next year of data. So that's all we got for tonight. Make sure you stay safe in the data mines.